All right, greetings, guys. So this is a tutorial video that will take you through every single question on that Unit 5A practice test as you guys begin to prepare for your upcoming test. All right, I'll take you through step by step each and every question. So what I recommend you doing, since I doubt many of you or any of you hopefully need help on all of the questions, I just recommend you fast forward to whichever question or questions you need help with, right? That way you don't have to sit through stuff you don't need help with. But I am going to be going through every single question on this test. All right, and it seems logical to start with the very first question. All right, so this question is asking, right, either just to remember what falls on what side of our arrow, right? So we have this arrow that means yields. That means that in this case I'm starting with H2O2, which we don't even have to know the name of that. That's hydrogen peroxide, by the way. And I'm ending with water and oxygen gas. And it's asking what would we call the oxygen gas in this reaction? Well, I've taught you, right, that this side of the reaction is our products, this side is the reactant, so we would say that the oxygen gas is a product, letter A. Moving on. All right. So what requires slightly more thinking, right, is identifying reaction types based on patterns, right? So again, what we're looking for is one of our 5 patterns, right? We've got the A plus B yields AB, which is our combination or synthesis. We've got AB yields A plus B, right, which would be our decomposition. All right, so again, all we're looking for is what do we start with, what do we end up with, and how are the materials reconfigured on that product side, right, or predicting. So in this case, for combination synthesis, we start with 2 separates, we end up together. So that's combining or synthesizing a new compound. In the case of decomposition, we start with a compound and we split them up. So we're decomposing that compound. Right. Now, we've also got single replacement where we have a single element by itself, right? And that single element replaces one of the others. Or we've got, so that's our single replacement, we've got AB plus CD, so we've got 2 compounds, right? And essentially all we do is trade partners. So we go AB plus CB, right? Or we have what's called a combustion reaction, which is just some sort of hydrocarbon and oxygen gas, right? Producing CO2 and water every time. All right, so we're going to use that as our pattern. Now, you guys at home, when you are taking the test, I have no way of preventing you from having some sort of notes in place to help you identify these reaction types. So my expectation is you guys use those notes and get 100% quite easily on this part. All right, so let's look through each of these reactions and identify what pattern it is that we see. So what I see is a compound and a compound. So I'm going to call this an AB plus CD, right? There's really only one reaction type that matches that, so that would be double replacement, right? Second one, we have a hydrocarbon and oxygen gas producing CO2 and water. We need to automatically recognize that as a combustion reaction. All right. Next one, we got a single element and a compound. So this looks like an A plus BC yields AC plus B. So that is a single replacement. All right, we got an A and a B yields AB together. That is a synthesis reaction or combination reaction, however you want to do that. And here, looks like we've got a single compound splitting up into 2. That will be decomposition. All right. So again, looking for patterns, identifying what pattern we have, and then using that pattern to identify what type of reaction. We're going to limit you guys to those 5. All right, moving forward. Another multiple choice question, right? So putting this in perspective now, we want to move beyond simply looking at a written reaction that's already there for us, right, and identifying what type it is. We want to be able to make predictions about what we started with or what we end with, right? That's what good scientific theories do, is they allow us to predict things like that. So if it had a single compound and it decomposed to form K plus I2, right? In this question, I'm trying to figure out what's on my reactant side. Okay, so now what we have to do, this is the beginnings of synthesizing a previous unit, which is how do compounds form, like in certain ratios, right? And potassium being a metal, we know this is an ionic compound, so we need to look at the charges, right? So if you look at your periodic table, we should see that potassium is a +1, iodine is a -1. So they're going to combine in a 1-to-1 ratio, making the correct answer to that letter B, right? So we have to use our charges for our ionic compounds, right? And not just simply try to throw some random subscripts in there. That is not appropriate, right? We learn how to write formulas for a reason, and that's so that we can understand how much of one element combines with how many atoms of another element correctly, okay? Next one, okay, it says the complete combustion of which of the following substances produces carbon dioxide and water, right? So again, we are looking for, in our instances, a hydrocarbon. So in this case, we're looking for a carbon combined with hydrogen, and that will be letter C, right? We should recognize that when we have combustion, we produce carbon dioxide and water, right? We need a hydrocarbon and we need oxygen gas, right? Moving forward. All right, taking this one step farther, right? We need to now predict what products we are going to end up with, okay, using the patterns A plus B, C, etc., okay? And we need to write them in the correct way, right? So I did teach you guys in a previous lesson, right, that no, hydrogen is not does not form ionic compounds, but we can pretend, right, in our reactions it acts very much like a +1. So I'm going to write a +1 above that, a -1 above that, and a +2 above zinc. Even though zinc right there is not an ion yet, it will become an ion with a +2 charge, right? So now pluses replace pluses, right? And this looks like a single replacement reaction to me, right? So I'm just going to swap zinc and hydrogen. So in this case, right, I've got zinc at a +2 and chlorine at a -1. So it's going to be 1 zinc and 2 chlorines. So it's going to be ZnCl2, right? To get a perfect score on this question, I need to put that little 2 there because that is the correct formula for zinc chloride. Now, what we're going to be left with then is hydrogen, and many of you guys may just put a plain H there. Right? I did also teach you guys once upon a time that there are 7 diatomic elements, which means that when they're by themselves, right, they become in 2s. So that would be bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine, right? So Brinkelhoff is the little acronym I taught you guys. That just means that each of these, when they're by themselves, they are diatomic, right? And I don't want to go into the bonding reasons for that right now, but that's just what they do, okay? So that's why I would need that little 2 by that hydrogen, by the way. Okay, next one. Looks like I've got an A, B, C, D, right? Sodium being a +1, carbonate being a -2. Whoops. Sorry about that. -2, right? In this case, lead being a +2, nitrate being a -1. And all I'm going to do is I'm going to swap my cations, right? So my A and my C are going to swap places, but I need to then write the formulas correctly. So I'm going to combine a +2 with a -2. So my lead and my carbonate are going to join together, right? They have equal charges, so it's just going to be a single lead and a single carbonate ion, right? And I'm going to combine sodium with nitrate, which is going to be a +1 and a -1. Again, the charges balance it out, so it's just going to be a single sodium and a single nitrate. All right, we've got an easy one coming up. Hydrocarbon plus oxygen gas produces carbon dioxide and water. And it does not matter which one of those you write first, by the way. All right, and we got H3PO4, also known as phosphoric acid. You guys wouldn't know that, right? And then we have what's called calcium hydroxide. This would be a simple acid-base reaction. Not that you guys need to know that at the moment. But again, we're going to treat hydrogens like a +1. Phosphates -3, calcium's a +2, hydroxide's a -1. Again, you guys need to recognize your polyatomic ions, though. You guys have that sheet of polyatomic ions. At least you ought to with their associated charges. That's how I'm getting those numbers, by the way. Okay, so it looks like another double replacement reaction, which means I'm going to be swapping partners here. Hydrogen is going to combine with hydroxide. Calcium is going to switch with the hydrogen here, so I'm going to go calcium 2 and a 3 here, so I'm going to go 3 to the calcium, 2 to the phosphate, Ca3PO4 2, and a +1 with a -1, so I'm just going to go HOH, which you guys might recognize as water. All right. And last but not least, now, I will tell you guys, because of the format of the test, you're not going to have to do questions just like this one, where you write out the complete reaction. You will need to know how to do what this question asks of you, though. So in other words, don't just skip over this one because I just said that, but I also don't want to scare you. All right, so this is sort of like a full synthesis of what we learned so far, right? We're going to start with names. So I'm not giving you the left side or the right side of the reaction. You have to write out the entire reaction. So you're going to write the correct formulas for the reactants, right? You're going to predict what those products had to be, and then also write the correct product formulas for those products, right? So here we have lithium. Lithium all by itself. That's a simple one, right? It's going to react with hydrochloric acid, and I even give you that formula because we've not taught you guys the acid naming and formula rules yet. All right? So I need to now predict what my products are going to be. So I would predict this follows that single replacement reaction, right? And with hydrogen being acting like a +1, chlorine -1, lithium +1, I can then predict that I'm going to make lithium chloride, right? And the hydrogen will be off by itself. And if you guys remember, whenever hydrogen is by itself, it gets a little 2 by it. Ba-doom. All right, next one. I've got aluminum nitrate. So that's an Al3+. Okay, nitrate. Notice it does not say nitride. Nitrate. The ATE tells me it is my polyatomic ion, which is an NO3, and that's a -1, right? And that reacts with, so I'm going to sodium phosphate. But let's first write my formula for aluminum nitrate. So I've got a -1 here associated. So the 1 goes to the aluminum, the 3 goes to the nitrate. So I'm going to go AL parentheses NO3. 3, all right? And that is going to react with sodium, which is Na+, and phosphate, again, that ATE. It's not phosphide, which would just be phosphorus. It's phosphate, which is my polyatomic ion, which is a PO4, and that's a -3 charge. So the 3 will now go to the sodium, 1 phosphate, so I'm going to say Na3 PO4. Now, those are going to react, right? So now I need to predict what those products ought to be and write the correct formulas for those products. So aluminum, right, is a 3 plus, 1 minus, 1 plus, 3 minus. Okay? So this is a classic double replacement reaction, in which case I'm going to switch partners here. My sodium is going to combine with nitrate. My aluminum is going to combine with phosphate. Right? So, whoops. Excuse me. So I'm going to have aluminum phosphate, AlPO4. Right? They are both 3s, so there's no need for an additional subscript because they have equal opposite charges. And likewise with sodium nitrate, they are both 1s. There's going to be 1 of each. All right. Hydrogen peroxide, H2O2, decomposes to form water and oxygen gas. So that is H2O2 by itself is going to split up into water, which you guys should recognize as H2O, and oxygen gas, right? But I can't just leave that single O there, because what does oxygen do when it's by itself? It is a diatomic. It's one of our 7 diatomic molecules. All right. That wraps things up. I hope this helped you guys. If you had any questions going through that practice test. Otherwise, best of luck on that upcoming test.